Today's Daily Dose of Math is about the degree of a polynomial, which is terminology in polynomials that refers to the highest degree of any of the terms in the polynomial. So let's look at figuring out what the highest degree of a term is. In this example, x cubed plus 5, the 5 is a constant term. It doesn't have a variable, and it doesn't have exponents of the variable. But the x cubed, x is a variable, and the 3 is the exponent of the x. So of these two terms, the one that has the highest degree is the x cubed, because it has an exponent of 3. And that means this is a third degree polynomial. So what we're doing is we're looking at each of the terms, deciding which term has the highest degree, figuring out what that degree is, and that is then considered to be the degree for the whole polynomial. In this second example, we have 3x squared minus 2x plus 6. The 6 again is a constant term. It doesn't have a variable at all. The minus 2x has a variable, and the exponent of that x is 1, the one that we normally don't write down, but is always there. But over here we have 3x squared, and the exponent of x in this one is 2. This is a second degree polynomial. Because the term with the highest degree is this term, and its degree is second degree. In the third example, we have a constant term minus 3, which we will ignore because we have plus 2x, which is of a higher degree. The exponent is a 1. But we're ignoring that as well. We're looking at these two terms because the degree is higher. Here we have xy cubed, which means x to the 1, y to the 3. And here we have x cubed y, which is x to the 3, y to the 1. But what we do to determine the degree of these terms is we add the exponents of the variables. 3 plus 1 is 4 in both cases. The degree of this polynomial is 4. And which of these terms is responsible for that? Both of them, because they're in a tie for the highest degree terms in the polynomial. But remember, when you get a term that has more than one variable, you add the exponents of those variables in order to figure out the degree of the term and of the polynomial. And that means, of course, that this one, we will ignore the 7 because we have x to the 6, y to the 5 here. We add those together, and this is an 11th degree. Hard to write, but easy to figure out. One of the reasons we want to know this is that in math we deal with equations like these. And one of the things we have to know is the terminology for the equations. This equation, which is the equation for a straight line, is considered a first degree equation for the same reasons that we applied over here. The highest degree of any of its terms is 1, because 2x to the 1 is the term with the highest degree. That 1 means this is a first degree equation. And therefore, in this equation on the bottom, y equals 3x squared plus 7x minus 4, we have constant term, we have a term with x to the power of 1, but we have a term with x to the power of 2. That's the highest degree of my terms, and that's what turns this into a second degree equation. That's today's Daily Dose of Math. Please like, subscribe, and share.